Hey, welcome back, everybody. Savas Algebra 2. Taking a look at some trigonometry in lesson 7-6. I think right at this point, though, we are looking at some review questions here with some transformations. And all of our key features that we've supposedly learned early in the year and that we don't want you to forget. So let's take a look here and see what we've got going on. For this function, find the inverse in the domain and range of the function. Determine whether the inverse is a function. All right, so we got 4 parts to this question here, and let's get started. Choose the correct answer for the inverse. So my favorite technique for doing the inverse, there's different ways you can do this, but this f of x is sort of like a y. So I swap the x and the y because the inverse is when the formula will undo this formula. That's what an inverse is, something that undoes the other one. So we're going to have a negative. And again, this is just my favorite way to do it. And I'll rearrange the equation to solve for the y value. It's a pretty popular technique for doing this. But we'll move that 5 over. So I'm subtracting it from both sides. Hopefully you've done enough of those by now that my shorthand just explaining that verbally, you know that I'm subtracting 5 from both sides or adding a negative 5 to both sides. Next, I'm going to multiply both sides by a -1 to get rid of this negative. Sometimes I would also explain that in a slightly different way. So that's one way. It's going to turn it into the negative x plus 5 and equal to the y squared. I've also seen that same step that looks like that explained as, and I don't know, I kind of like this one just as well or better. If I add the y squared to this side and then do the opposite of both of these to that side, I'm going to get y squared equals a negative x plus 5. So whichever one of those, they both work out the same. The second one, for me, just seems a little faster in my brain if I can wrap my mind around that's what I'm doing anyway. And so then to get the y alone, I'm going to square root both sides, remembering when you square root both sides, if I told you that x squared was 25, which I often do this in class and say, all right, what's x? And over 50% of the class will tell me that x is 5. That's great. And I say, oh, but you just got half credit because you only gave me half the answer. If I do 5 times 5, yes, that's 25. But what about -5 times -5? That's also 25. So when you square root both sides of an equation of a problem that is in that format, you are going to get both a positive and negative answer because the positive of that number and the negative, when you square it, are going to come up to the same thing like that. So down here, we're looking for this one, the positive and the negative of the square root of, well, negative x plus 5 is the same as if we rearrange these, the 5 and the negative x. So this one right there would match that. So let's see what Savas has to say about that. All right, well, moving on then to the next step. What's the domain and range of the, well, now this domain and range, they're talking about the original function or the inverse function? Like, we just did the inverse, so the domain is all the real, so it's talking about the original function. The original function was a parabola opening down, right? If we're talking about this one, that was a parabola opening down because of the negative, but moved up 5. So that's a parabola that looks like that. So my domain goes forever left and right. So my domain would have been all real numbers. My range, my domain, the x's, my range here would be down forever going down, right? The range, how low are these? And then my, how high does this graph go, the maximum? To the, that was the one that was moved up 5. So it goes up to the 5, it hits the 5. Infinities are always, so, and remember if it's all real numbers forever left and right, if it was talking about interval notation could be like that. So if it's talking about the original, if it's talking about the inverse, we're just going to flip that domain and range around. So let's just see. The domain is all real numbers. And I think we're talking about the original function here, not the inverse. And then the range is, no, that's not the range isn't all. The domain is all real numbers. And the range are all the y's that are less than or equal to the 5. So that's the one that I think we're talking about, unless we're talking about the inverse, and we got to flip it around. So let's see. Okay, we were talking about the original function. Didn't say inverse. And then it says, what are the domain and range of the inverse? So now we're going to flip that around, because just like we switched the x and the y around when we wrote the equation to solve, right down when we went from here to there, that's the inverse. We're going to flip the domain and range around when we come over here. You can also think about it, remember when we did square roots. This is a square root, the negative x, so it's going to be, if you, opposite of your x's, the square root of x graph opens that way. When you put a negative on your x, all your x's are going to be going the opposite. And the negative on the 5 there, or positive 5 on the x, to move it 5 to the left. But if we can also just come back here, switch your domain and range around. So but we can't have the range here be all real numbers, because remember this goes 5 left. If we flip that around, it's going to be going the wrong way. So all of the x's that are less than or equal to 5, but the range is only from 0 going up, or domain all real numbers, domain x's that are greater than 0. So the other thing, if we've done Desmos quite a bit, we could just throw this problem into our Desmos and take a look. What's the problem look like if we graphed it? So we've got that. Our graph was y equals, and again, we can do the square root of the 5 minus x, 5 minus x. So there was the minus x and the 5 to the right. And then you could also do the negative part, because we had the plus and minus when we did that. But watch what happens if you do this. You're going to have a negative on the square root. This is not going to be a function, because for every x, you can only have one y. And if you took a look at like this point right here of x, you've got 2 different y's. So we usually disregard the negative side of that one and limit the domain. So our domain is of the original functions. So our x's are going to go forever to the left, and our y's will go forever up when we're looking at our answer here. So our x's, everything less than 5, and range all real numbers, the domain all real numbers, domain x's that are greater than 0, the domain is all real numbers, and the range is the y's that are less than the 5. The domain and range, I didn't see any of those that match what we just saw on here. The domain would be all did I type my equation correctly? The 5 minus x. And we can't do this second one, or we don't have a function. So talking about this one, my domain on this function, if it's talking about on the original, it's when you flip it. So the domain of the original function, x would be less than or equal to the 5, and the range, boy, I'm tempted to put this one, but if we do, that really isn't a function. So they're not limiting it to being a function on just the bottom half of that graph. All right, then, is the inverse a function? Well, if we included both parts of it, the answer would be no. So, but if we limited it, then it would be. So I was just thinking we already talked about that, but they're thinking we haven't really discovered we're going to limit that. So those are the ways they're looking at how to answer that question. Good luck, everybody. Have a great day.